Absolute value is the distance a number is away from zero. When we measure distance, distance is in a positive unit. So when I put anything negative into an absolute value bracket, I have to make that value positive, which is why my absolute value function is a giant V. Any of my negative numbers that get put into that absolute value are going to give me an output of a positive number, which is the y coordinate, which is why all of those negative numbers on the left have positive y values. Now we want to transform an absolute value function. This is its standard form in which it gets transformed. Now this format is very similar for other functions as well, so they all transform in a very similar manner. So the A is going to indicate a reflection over the x-axis if it is negative, and then any value, so any number, is going to indicate a vertical compression or stretch. The H is going to tell us if it goes left or right. Now if you notice, left is addition and right is subtraction, and that is because of the negative subtraction sign in front of that H. And then the K indicates our up for positive and down for negative. Now the vertex of our absolute value is the point of the V, and the vertex can be found by the H and the K. So however many the absolute value function has moved to the left or right and up and down. Here we have 4 examples of transformations. So what we want to do is identify each transformation and then the vertex of the absolute value function. So you always want to start in the very beginning of the absolute value bracket. I have no value for A, so I'm not going to be reflecting over the x-axis, and I am not going to be vertically stretching or compressing. If I look on the inside of my absolute value bracket, I have an x plus 3. With the plus sign, that means I'm going to be going left 3 units. And on the outside, I am subtracting 1, so that means I'm going to be going down 1 unit. Now to find my vertex, the left and down are going to tell me where it's going to be located at. If I am going left from the origin, that's going over to -3. And if I'm going down, that is to -1. So my vertex will be at -3, -1. In my second example, I have a number in front of my absolute value sign. So it's going to be a vertical stretch, because stretches are numbers that are larger than 1. So this is a vertical stretch of 3. And then if I go inside my absolute value sign, I have an x plus 4. So it is similar to the last problem, and it's going to be going left 4. I have no addition or subtraction outside of my absolute value, so this function is not going up or down. So when I find the vertex, this is only going over left 4 units from the origin, so it's going to be at -4, 0. In our third problem, in the front of my absolute value sign, I actually have a -2, so this is a little different. The negative sign tells me that I'm going to be reflecting over the x-axis. Any negative sign here will show that reflection. The 2 is going to be showing me that it is a vertical stretch again. I don't worry about the fact that the negative sign is there. That negative is only responsible for the reflection. The 2 will be responsible for the vertical stretch since it is bigger than 1. If I go to my absolute value sign, all there is x, which means that I'm not going to be moving left or right. So if I go to the back, I have a +1, which means I am just going to be going up 1 unit. So to find my vertex from the origin, I'm only going up 1, so my x is going nowhere, so that will stay at 0, and my y will become a +1. My last example, I have a +7 in front, so that too is a vertical stretch. If I go inside, I have a -1, so that's going to indicate a right 1, and my +2 will tell me that I am going up 2. Since my vertex is going right and then up, my vertex is going to be at +1, +2.